Alright guys, some students, they have asked me to redo this problem, which is the Atwood machine, and how we are doing the equations. And I know it looks confusing because I was explaining each and everything, but I am redoing it now with proper focus and quick. But I have to mention a few things, that I will follow the sign, the rule of sign, that with the direction of motion minus against the direction of motion. So for example here, if the elevator is moving like that, this is coming down, this is coming up, so we consider this is the dimension of motion. Whatever is with the dimension of motion is positive, minus whatever is against the direction of motion. All right. The other thing, Ft, which is the tension in the rope, is always towards the pulley in both cases here. So it's always towards the pulley, and it's the same at any point in the rope. It doesn't matter whether it is the tension force for the elevator car or for the counterweight. So Ft is the same. Ft direction is always towards the pulley. Keeping this in mind, let's do this problem without explanation, like, just go and solve it. So what he's asking in the problem, let's see. I want to basically, okay, basically this is the problem here. What is given, I will put a new page. So what is given here? The mass of each thing is given. Okay. Mass of the elevator is given. Mass of the counterweight is given. What else is given? I think that's about it. And he's asking about the acceleration of the object. Okay. And I think he's also asking about the tension force as well. Let me just double check what is required and what he's asking. So you see here, he's mentioning the things, and he said that, he's mentioning that then MC and ME, and that's it actually. There is nothing else in the problem except the masses of the objects, and calculate the acceleration of the object, of the elevator, or the acceleration of the system, and the tension in the cable, So he's literally, either we say the acceleration of the system, the acceleration of the elevator, it's the same, and he's saying the tension in the cable of the elevator. And the problem is like that. This is the pulley, and okay, this is the pulley, and this is the cord, which is weightless, and the pulley is frictionless, and this is the elevator. So this is ME, and this is the counterweight. It is all the same cord. Okay, this is the same cord, and it's going down here. Okay, this is the counterweight, so this is MC, and these are the only two things which is known. But I think he's explaining here that ME, this is the direction of motion basically at this moment. Okay, so the counterweight is going up and the elevator is going down, so this is the direction of motion. And we have to mention that acceleration is the same for both objects, tension is the same for both objects, and it's towards the elevator. You have to figure this out first, that this is acceleration, it's the same but not the same direction. Now, what are the other forces acting on the objects? It is the force of gravity, which is ME times G, and same thing here, it's force of gravity, which is MC times G. Nothing else is there. There is no normal force. There is nothing, no friction force, because we don't have surface here. So what do we do? And all the motion is along the y-axis. There are no equations along the x-axis. But we have here two objects, ME and MC. So we have to write the equation of motion in the y direction for both objects, for object E and for object C. And the acceleration is the same. I am not going to say mE times acceleration of object E, mc acceleration of object C. Why? Because A of object E is equal A of object C as value. But of course the direction is different. Now, what are the forces acting on object E? The Y forces. كمان again, we say with the direction of motion against the direction of motion. So the forces are with the direction of motion, it's MEG, minus against the direction of motion, it's FT, is equal to ME times A. All right. Now what about MC? MC. So this is the direction of motion. This is the direction of motion. So what is with the direction of motion? It's FT. Against the direction of motion is MC times G is equal MCA. Make sure A and G are different than each other. The A is the right side of the equation in Newton's second law. All right. So now we have two equations with how many unknowns? Two equations with two unknowns, because A is the same for both objects, FT is the same for both objects. We have to solve for them. All right. How to solve for them? We can, so this is equation 1. This is equation 2. You can put equation 2 here so that we can solve them mathematically. So this is MC, no, I mistake. All right. So this is FT minus MCG is equal MCA, and this is mathematics. It's two equations with two unknowns. Elimination and substitution, it's up to you. This is math. I would just add them up to each other because I can eliminate the FT. I can eliminate the FT and I will end up with ME times G minus MCG is equal, we are adding them up, MEA plus MCA because we add up both equations. So G is common factor, ME minus MC is equal, A is common factor, ME plus MC. That's it. You plug in the masses. G is known. What is the value of A in meter per second square? Don't memorize these kind of formulas. It will be wrong if we switch directions or something. And then how to find the tension? Just you choose any of them. You choose equation 1 or equation 2. A is known, ME is known, G is known, ME is known, so you can find FT. And it will be in Newton. All right? And that's it. Thank you.